It started with a slight shift, a deviation so subtle most telescopes didn't notice. But when 3I Atlas drifted near Earth on December 18th, it revealed something even more startling than its orbital change. A sudden burst of peak activity, concentrated jets, and directional tail features that don't fit any standard comet model. Comets drift. They break apart. They follow predictable paths that react passively to sunlight. But this object, it adjusted. Not in chaos, but in rhythm. And that rhythm now matches Earth's quadrant as it closes in for its closest approach. Across observatories worldwide, from the VLT in Chile to Pan-STARRS in Hawaii, the instruments caught a change in real time. A pattern of movement emerged, but not one expected from solar gravity alone. The object's behavior was precise, timed, and strangely, active. This wasn't a chaotic outburst. This was a calculated drift. A moment where the object, after months of travel through the inner solar system, approached our planet not just with momentum, but with momentum laced with structure. Today, we follow the path of 3I Atlas as it passed just beyond Earth's orbital flank, not colliding, not fragmenting, but glowing, responding, emitting. And for a brief window, revealing something about itself no one was ready to admit. Because what we saw on December 18th forces us to confront a question we've been avoiding since its discovery. What if this object is not just reacting to the solar system, but navigating it? Let's walk through the evidence. For months, astronomers believed they had a reliable trajectory. Every simulation, every orbit model, every JPL ephemeris pointed to a stable, hyperbolic path, a clean exit after perihelion, untouched by planetary gravity. But on the morning of December 18th, just as 3I Atlas reached its closest lateral approach to Earth's orbital corridor, something shifted. It wasn't dramatic, it wasn't explosive, but it was undeniable. At first, the numbers seemed like calibration noise, a 1 in 1,000 drift in arcseconds, perhaps due to solar radiation pressure or residual outgassing. But when the same deviation appeared independently in 3 data pipelines, NASA's Jet Propulsion Laboratory, ESA's Gaia-based orbital fitters, and the Canadian Space Agency's deep field trackers, confidence levels spiked. The object had changed course, and the change wasn't random. Instead of veering outward or falling inward, the path of 3I Atlas gently curved. Inward, laterally, sliding along Earth's orbital plane. The angle was less than a degree, but at the object's velocity, over 200,000 kilometers per hour, that arc represented millions of kilometers of deviation over time, a ghost trajectory, one that would place it closer to Earth than originally predicted, without ever entering direct impact danger. It was not a threat, but it was intentional, and that was the problem. Because orbital drift isn't new. Comets, asteroids, even interstellar bodies like Oumuamua have exhibited what scientists call non-gravitational acceleration. Typically, these are attributed to jet activity, vaporized ices emitting from surface fractures, producing tiny but cumulative pushes over time. But those pushes are messy. They cause wobble, spin torque, even fragmentation. They do not produce what 3I Atlas had just done, a clean, smooth, consistent drift. The timing added to the mystery. The deviation began days after perihelion, then peaked just as the object reached Earth's orbital flank. The symmetry was too perfect, the window too narrow, and most critically, the motion matched no known behavior of a passive natural body. Some proposed a late-stage jet activation, an internal reservoir of volatiles reaching solar exposure. But the object wasn't tumbling, its spin was stable. For a jet to activate with that level of directionality, it would require either internal geometry beyond anything previously modelled, or, as some quietly began to suggest, a deliberate timing mechanism, a response, not a reaction. That distinction became the turning point, because comets react. They fragment, spiral, flare. Their motion is chaotic and usually unpredictable, but 3I Atlas adjusted. It altered its outbound arc in a way that minimized solar wind drag. It didn't swing around Earth. It flowed past it, in parallel, matching the orbital speed of our planet almost exactly for a brief window of time. For over 45 minutes, it moved in lockstep, not behind us, not ahead of us, but with us. A ghost companion, just outside the line of sight. No one expected that. In astrodynamics, such a move would be called a gravity-neutral coasting phase, a maneuver seen in advanced satellite flybys where minimal fuel is used to adjust alignment without triggering unnecessary trajectory change. But 3I Atlas isn't a spacecraft, or at least that's what we thought. As the data accumulated, analysts at NASA, ESA, and independent observatories issued quiet internal memos, not because they believed the object was artificial, but because they couldn't explain how something moving that fast, with no visible means of propulsion, could perform a drift that clean. That's where the science paused, and the questions began, because from that moment on the rest of its behaviour would only get stranger. As 3I Atlas moved into Earth's orbital flank on December 18th, telescopes around the world began to report something strange. Not a crisis, not a disintegration, but a moment of activation. Instruments that had been tracking the interstellar object for months suddenly picked up synchronized activity across multiple wavelengths. And unlike earlier outbursts triggered by solar heating near perihelion, this one didn't come from thermal pressure. It came from stillness. Before this moment, 3I Atlas had maintained a steady decline in visible activity. Its coma, the halo of gas and dust that surrounds cometary nucleus, had begun to thin. Jet signatures were fading. Spectral lines associated with water vapour and carbon monoxide had dropped below typical detection thresholds. To most observers, this indicated the comet was entering a quiescent phase, expected behaviour for an object cooling down as it moved away from the Sun. But then something reversed. Shortly after the object completed its orbital drift toward Earth's quadrant, a new dataset arrived from the James Webb Space Telescope. Its infrared sensors detected a spike in carbon dioxide emissions, a signature normally associated with deep cryovolcanic activity or sudden solar re-exposure. But 3I Atlas wasn't rotating into sunlight. It was already well past its closest solar distance. It shouldn't have been heating, and yet its emissions surged. Ground-based observatories confirmed it. The coma brightened, but not in the typical expanding halo pattern seen in sublimation-driven events. This coma was narrow, compressed, almost aerodynamic, and the jets? They were symmetrical. From 3 distinct locations on the object's surface, jets of vapour and dust began firing in unison. They didn't pulse irregularly. They fired in coordinated bursts with intervals matching a rhythm later calculated at just under 12 minutes. The alignment of the jets was precise, forming a triangle of force vectors that, when modelled, showed not random dispersion, but a coherent thrust pattern aimed away from the Sun and perpendicular to the object's trajectory. The implications were troubling. Jets of this kind are not uncommon on comets. Surface fractures and trapped volatiles can erupt violently when exposed to sunlight, often spinning the comet or creating momentary flares. But they don't stabilize the motion, and they certainly don't coordinate. Yet 3I Atlas was doing both. Its rotation, already unusually stable, became even smoother. Observers noted that the object exhibited no signs of wobble, no phase shift in its brightness curve, no signs of torque despite the increased outgassing. That stability, combined with directional thrust, suggested something unthinkable: control. And it wasn't just the jets. The entire body of the object seemed to respond in concert. Polarimetric readings indicated a sudden shift in surface reflectivity, increasing albedo across multiple bands. That could indicate frost exposure, or it could mean a structural rearrangement, like something opening. NASA's solar monitoring team flagged the anomaly in their daily report. ESA's solar orbiters recorded synchronized movement in the surrounding plasma, faint but visible. Something about 3I Atlas had changed. It was no longer reacting to solar pressure, it was acting. The timing coincided exactly with its lateral drift near Earth, and that detail didn't escape the notice of heliophysicists. The object was not just passing through, it was reaching a point of peak efficiency, a moment where its path, velocity, angle, and sunlight alignment all intersected, and in that window it activated. This wasn't survival, this was manoeuvring, because in the minutes that followed, the jets intensified, the coma narrowed, and 3I Atlas, the third interstellar object ever detected, began doing something no comet has ever done. It stabilized. and then it responded. The first indication that something was deeply wrong with our understanding of 3I Atlas came not from its orbit or its jets or its surface temperature, but from its tail. Specifically from what its tail refused to do. In every known comet, the tail behaves predictably. It forms as volatile gases sublimate from the surface and are pushed outward by solar radiation and the solar wind. These forces blow particles away from the Sun, forming the familiar luminous streaks that stretch behind the nucleus. The tail points away from the Sun, always. The physics are basic. It is one of the most foundational features in all of comet science. But on December 18th, just as 3I Atlas reached its closest pass along Earth's orbital corridor, its tail didn't follow the rulebook. Instead, it split. High-resolution imagery from the Pan-STARRS Observatory in Hawaii showed two distinct tail structures. The primary ion tail, which did in fact trail away from the Sun as expected, and a second feature emerging in the opposite direction. This was the anti-tail, and it was getting brighter. At first, scientists assumed it was an optical illusion. Anti-tails are not unheard of. In rare cases, they can form from dust particles previously emitted by the comet, now orbiting behind it, projected toward the Sun from Earth's point of view due to perspective effects. But this wasn't a perspective trick. Observatories across Chile, Japan, and South Africa confirmed it. Different latitudes, different angles. The feature was real, and then it got weirder. The anti-tail didn't just persist, it sharpened. Unlike the ion tail, which diffuses with distance and light pressure, the anti-tail of 3I Atlas appeared to focus into a narrow stream, not expanding, but compressing. Its structure held for over 7 million kilometers, with almost no measurable widening. That doesn't happen in dust, it doesn't happen in gas, it doesn't happen unless you're intentionally collimating the flow. At that point, comet scientists went back to first principles. Could this be a focused emission jet aimed sunward? That alone would violate every known thermodynamic model of outgassing. The Sun's radiation pushes away. Sublimation on the sunward side should cause tail formation away from the heat source, not toward it. And yet this was not only happening, it was happening symmetrically. Multiple images taken in succession showed the anti-tail narrowing over time. While the main ion tail pulsed, the sunward beam did not flicker. It held. Its direction did not shift even as the object continued its lateral slide across Earth's orbit. And then came the most critical measurement, its composition. Spectrometers focused on the beam and found high concentrations of carbon dioxide with trace silicates. Not fine water vapor or dust, but dense, heavier compounds. These materials should have had no reason to be ejected sunward, unless something was forcing them. Could a natural process eject mass directly into the solar wind and still maintain symmetry? Not with this precision. Not over this distance. Theories emerged quickly. One suggested deeply embedded pressurized gas pockets exploding along fault lines. Another proposed an internal reservoir capped by a crust that had ruptured in one direction. But none of these matched the data. The anti-tail's consistency, duration, and collimation implied more than random venting. It suggested containment, control, a vector system pushing mass against the pressure gradient of the solar wind, possibly to generate a counterforce, propulsion. And here lies the deepest fracture in the narrative, because a tail is supposed to follow a comet. But 3I Atlas wasn't followed by its anti-tail, it was driving it. As the tail structures of 3I Atlas baffled astronomers, attention turned toward the origin point of all that activity, the jets erupting from the object's surface. These jets, invisible to the naked eye but highly visible in spectroscopic and infrared imaging, are the engines of comet behavior. They form as frozen volatiles inside the nucleus, vaporize and escape into space, carving pathways through the surface and hurling material outward. In theory, they're chaotic. In practice, they're messy, but not this time. On December 18th, 3I Atlas displayed a jet pattern that was anything but chaotic. It was, in a word, disciplined. Images captured by the Gemini South Telescope in Chile revealed 3 main jets erupting from the surface at nearly equidistant points around the nucleus. This wasn't random. The spacing of the jets formed a geometric triangle, roughly 120 degrees between each plume. The orientation of the jets did not wobble or drift. Each one fired from a consistent axis, with no rotation-induced shift. The symmetry was unsettling. It was the kind of pattern one expects from a satellite's thrusters, not a comet fragment tumbling through space. But the most extraordinary part wasn't the geometry, it was the timing. Multiple observatories, from Mount Lemmon in Arizona to La Palma in Spain, captured time-lapse images of the jet activity. What they discovered was a rhythm. The 3 jets ignited in precise intervals, repeating every 11.8 minutes. First one, then a half-second pause, then the next, then the third, then all 3 would pulse together, and then it would reset. The pattern repeated over 8 full cycles before fading into silence. Some researchers suggested that the effect might be caused by the comet's rotation exposing jet sites in sequence, like a lighthouse beam. But that model collapsed under scrutiny. The object's rotation was too slow, too stable. Its light curve showed no evidence of tumbling or axial wobble. There was no spin-induced modulation. The jet pattern did not match any known rotation profile, which meant something else was governing the rhythm, the timing, the positioning, the non-interference with the object's motion, the lack of destabilization. All of it painted a picture of something more deliberate than natural. In standard comet physics, jets produce torque. When gases erupt from one side, the nucleus is pushed in the opposite direction. This causes wobble, spin-up, sometimes catastrophic fragmentation. But 3i Atlas remained serene. Its rotational state, observed over a span of 12 hours, showed no change. No torque, no precession, just linear motion, with bursts of mass ejection that should have caused chaos but didn't. Infrared analysis added another layer. Jet temperature was not consistent with exposed sunlight-driven sublimation. Instead, the gas appeared preheated, as though from internal pressurization rather than passive exposure. This suggested either trapped thermal energy or a mechanism for focused venting. Some proposed deep fractures connected to a thermal pocket inside the core. But again, no natural model explained the regularity of the pulses. The shape of the jet plumes was even more suspicious. Rather than fanning out broadly, they remained narrow, focused columns, several hundred kilometers long with clear boundaries. In simulations, this can only occur if the gas is being channeled, not erupting freely but passing through a confined aperture. In engineering terms, a nozzle. And that word, nozzle, became the one whispered behind closed doors in academic forums and lab discussions. Not because anyone wanted it to be true, but because the alternative was worse, that nature had spontaneously created a pressure and ventilation system operating with precision timing and geometrical balance on a body hurtling through space at more than 200,000 kilometers per hour. If nature did that, then we've misunderstood cometary physics on a fundamental level. But if nature didn't, then someone else might have. As the days surrounding December 18th unfolded, researchers noticed something about 3i Atlas that hadn't been seen before. Not in Oumuamua, not in Borisov, and not even in comets observed up close by spacecraft. Its reflectivity was shifting, but it wasn't random, it wasn't chaotic, it was responsive. At first, this was brushed off as a typical artifact of phase angle changes. When a comet moves between the Sun and Earth, the way light scatters across its surface can make it appear brighter or dimmer, depending on the observer's perspective. This is a well-documented phenomenon in observational astronomy. It happens with asteroids, moons, even planetary atmospheres. But what 3i Atlas was doing didn't match any known photometric model. It began shortly after the triple jet firing pattern was recorded. Astronomers tracking its albedo, the measure of how much light it reflects, noticed a series of synchronized increases and decreases, each occurring over precisely timed intervals. In the span of just 42 minutes, the object's visual brightness increased by nearly 50%, then returned to baseline just as quickly. And then it happened again. Not a flicker, a cycle. The sudden brightening wasn't accompanied by a plume event or sudden outburst, which is usually the explanation when a comet suddenly reflects more light. There was no dust cloud, no fragmentation, no tail disruption, just a smooth, uniform increase in the amount of light being bounced back toward Earth. At first, researchers believed it might be a calibration error in the photometry systems. But when 5 different observatories in 5 different countries reported the same rhythmic spikes in reflectivity, down to the same number of seconds, doubt turned to concern. The next logical hypothesis was rotation. that a particularly reflective surface patch was turning into view on a periodic basis. But this didn't hold up. The rotation period of 3I Atlas was already well established. It was too slow. The reflectivity cycles were occurring far too rapidly to be explained by a rotating surface alone. Then came the infrared readings. When the object's brightness increased in the visible spectrum, so did its thermal signature, but not in a uniform way. The heat wasn't rising from the tail or from the body in general. It was emanating from two consistent regions, small isolated zones near the object's midsection. The pattern matched something very specific: controlled surface heating. Suddenly the theories escalated. Some astronomers floated the possibility of subsurface venting, causing localized frost sublimation, temporarily increasing reflectivity. But even this would not explain the symmetry or timing. The object wasn't just getting brighter, it was doing it in perfect synchrony with jet activity, as if each burst initiated a thermal response that caused the surface to glow more brightly on command. This led some to propose a radical idea. What if parts of 3I Atlas's surface were coated with material that could change its reflectivity based on internal heating or energy pulses? In other words, active surface modulation. If true, this would suggest a level of internal structure far beyond the loose rock and ice piles that make up most comets. It would imply the presence of compartments, perhaps chambers, that could selectively alter energy output in response to internal mechanisms. This type of behavior is not found anywhere in known cometary dynamics. Nature, when it brightens, does so with chaos. It flares, it sheds dust, it fragments. But 3's Atlas wasn't fragmenting, it was adjusting, modulating, reacting, all without shedding mass or altering its course. The reflectivity cycles also aligned with Earth's line of sight. Each time the object brightened, it was perfectly aligned with our observational path, as if whatever was causing the pulse wanted to be seen, or at the very least didn't mind being observed. Whether that was a coincidence or an intentional act remains unprovable. But the precision of the timing, the absence of chaos, and the measured way it happened suggested a level of control, and that word, control, doesn't belong in natural comet descriptions. Not until now. By the late morning of December 18th, one of the most unexpected data points came not from optical telescopes or infrared sensors, but from magnetometers. At first glance, this seemed irrelevant. 3's Atlas was too far out, too small, and not electrically charged enough to register anything meaningful on Earth-based magnetometers, and yet a low-frequency magnetic signature was showing up. Not everywhere, not globally, but in a very narrow band of Earth's magnetic field, directly in the corridor aligned with 3I Atlas's path. This anomaly was first picked up by the European Space Agency's Swarm satellite constellation, which monitors Earth's magnetic field from low orbit. One of the satellites in the trio detected a subtle but measurable shift in local geomagnetic intensity. It wasn't a spike, it was more like a sustained ripple, barely above background noise but real. The data was flagged, checked, dismissed, and then quietly revisited. It didn't match any known space weather activity. There were no flares from the sun, no incoming CME, and no lightning storms or ionospheric events to account for the change. But as the readings were compared over the next several orbits, something became clear. The ripple was following 3I Atlas. That revelation triggered immediate coordination with ground-based very low-frequency VLF antenna arrays. These instruments can detect shifts in Earth's electromagnetic environment with extreme sensitivity. Sure enough, the VLF readings in Antarctica, Greenland, and northern Canada began showing a correlated dip at precisely the same time that the swarm data showed magnetic flux. More alarming, the VLF signal was cycling in a rhythm that nearly mirrored the previously recorded reflectivity shifts from 3I Atlas. This isn't something we associate with a comet. Traditional comets don't emit magnetic fields. They can interact with solar wind, sure, and sometimes build up a weak-induced magnetosphere if they're shedding a significant amount of ionized material. But there was no evidence of that here. No plasma tail, no charged outgassing, just a stable body in motion. So how do you explain a stable object that emits magnetically synchronized pulses? One theory suggested a piezoelectric effect. Certain materials under stress can emit electric and magnetic fields, especially if they contain quartz-like or crystalline compounds. But for that to be sustained and rhythmic, the internal structure of 3I Atlas would have to be organised, something more than frozen chaos. Another explanation posited an internal rotating mass, something like a gyroscope or a dense core with high conductivity, spinning inside a less dense shell. If such a system existed, it could, under very specific circumstances, generate a magnetic moment detectable at a distance. But both of these explanations ran into the same problem. They required internal complexity, they required symmetry, they required balance, and natural comets, especially interstellar ones, are not balanced. This is where some researchers began to quietly consider the implications of engineering, not proof, not confirmation, but plausibility. After all, if an object were engineered, intentionally constructed to travel vast interstellar distances, it would make sense to embed navigation or orientation mechanisms inside. These could include magnetic balancing systems. They could include heat shielding layers that respond to solar input. They could even, hypothetically, broadcast low-frequency signals as part of an internal guidance network. If such systems existed inside 3I Atlas, then what we were seeing was not random. It was telemetry. The idea of a comet emitting its own magnetic field, targeted, rhythmic, aligned with Earth's sensors, was no longer science fiction. It was data. And that data said one thing: this object wasn't just passing through, it was announcing itself. Just when scientists began adapting to the strange reflectivity and magnetic behaviours of 3I Atlas, another phenomenon forced itself into the spotlight, something far more unsettling, because it had no precedent. Multiple deep space observation facilities, primarily those that monitor exoplanet transits through gravitational lensing, began picking up a distortion in their measurements. These distortions were first recorded by accident. One team at the Cerro Tololo Observatory in Chile noticed that background starlight near the path of 3I Atlas was behaving erratically. Starlight that should have remained steady was bending, subtly but detectably, at the fringes of their imaging fields. Not dimming, not flickering, bending. This wasn't caused by atmospheric turbulence, nor was it the result of poor calibration. These were controlled high-altitude telescopes with millisecond precision. Something was affecting the path of light as it passed near the projected course of the object. When the data was compiled from additional observatories in Hawaii, South Africa, and the Canary Islands, the effect became undeniable. There was gravitational lensing, but it wasn't centered on the object. This was the part that broke every model. In Einsteinian physics, gravitational lensing occurs when a massive body warps spacetime, bending the light from objects behind it. It's how we detect exoplanets, galaxy clusters, and even black holes. But 3I Atlas isn't nearly massive enough to create such an effect. Its mass is negligible compared to even the smallest moon. And yet, light behind it was warping, but not at the core, not at its centre of mass. The bending occurred near its edge, just off the limb of the comet's Coma. In some cases, it seemed to trail behind the object, as if something invisible was interacting with the light after it passed 3I Atlas. That shouldn't happen. Some scientists proposed a refractive dust halo, or an optical illusion caused by volatile gases. But once again, the object wasn't producing gas or dust in quantities sufficient to alter the light path on that scale. Nor would dust explain the distortion of background stars miles away from the comet's centre. Then a controversial possibility was raised: artificial lensing. This would mean the object had created a local space-time anomaly, either through mass manipulation or gravitational redirection, a type of field effect, perhaps generated by internal dynamics or hidden structures. That theory bordered on the speculative, until data showed that the same lensing zone moved in sync with the previously reported magnetic ripple. When the field shifted, so did the gravitational distortion, always slightly off-centre, always trailing. This suggested something was not just riding inside the comet, but perhaps attached or tethered behind it, something we couldn't see directly, but that carried mass or influenced the geometry of nearby spacetime. In effect, 3I Atlas might not be travelling alone. It might be dragging something behind it, something invisible to light, but not to gravity. That idea drew comparisons to gravitational wake patterns left by artificial satellites or the faint shadow zones produced by exotic matter. Again, no proof. But the repeatability of the distortion made it impossible to ignore. And for the scientists who had spent years scanning the cosmos for gravitational echoes, this was not just weird, it was deliberate. Something was bending space where nothing visible existed, and space does not bend unless something is forcing it to. By the evening of December 18th, just over 24 hours before its closest approach to Earth, 3I Atlas began exhibiting a behavior that contradicted nearly every foundational law of celestial mechanics. It fired jets, but not in the way comets do, not in the direction physics predicts, not in the direction momentum would allow. Cometary jets are typically caused by solar heating. As sunlight warms the surface, frozen volatiles sublimate, ice turns directly to gas, and the expanding gas vents outward, creating jets. These are beautiful to observe but predictable in direction, always trailing behind the object, opposite to its trajectory, and shaped by solar wind. But the jets observed on 3I Atlas had a different character. They didn't fire backward. They didn't even fire laterally. In several recorded cases, the jets fired against the object's momentum vector, that is, in front of the object into its path. That makes no sense for a natural comet. It's like stepping on the brakes while accelerating down a freeway, with no mechanical reason to do so. High-resolution infrared footage from the Sophia Observatory, before its decommissioning, revealed concentrated heat blooms forming at the front left quadrant of the comet. These weren't casual outgassing events. They were controlled, rhythmic bursts. They didn't scatter, they pulsed. But the strangest detail wasn't their placement, it was their timing. The jets appeared just before key orbital adjustments. Each time a minor course correction was detected, each time 3I Atlas altered its angle slightly to maintain alignment with Earth, the jets preceded the change by precisely 6 seconds. That timing was consistent across multiple orbits, and it pointed to something deeply engineered. If the jets had been a byproduct of solar heating, they would have fluctuated with temperature, rotation, or exposure. But they didn't. They operated like thrusters, like attitude control mechanisms, and their symmetry was too clean. Some astrophysicists argued it could be coincidental, fractures opening on the sunlit side of the nucleus, exposing new volatile pockets. But those same models couldn't explain why the jets led orbital changes rather than responding to them. A few went further. They began describing the jets not as byproducts, but as inputs. In other words, the jets weren't reacting to the comet's environment, they were steering the comet through it. That claim, once considered fringe, gained momentum when China's Jihe solar satellite captured ultraviolet imaging that showed the ejected material forming a spiral, not a fan. The gas exited in a corkscrew pattern, indicating rotational force as well as directional thrust. This type of spiral outflow has been theorized in propulsion physics, particularly in discussions around non-chemical spacecraft propulsion systems. Think Hall effect thrusters or plasma pulse engines, but no one expected a comet to replicate them. Even more alarming was the consistency of the exhaust signature. Spectroscopic analysis revealed a high presence of hydroxyl radicals and carbon monoxide, but in ratios far too even to result from random volatile exposure. It was as if the ejected material was being controlled, metered, and released with intent. So what does that mean? It means we might be looking at propulsion, not erosion. It means 3I Atlas is not just hurtling toward Earth on a passive trajectory, it is steering itself there, using jet behavior we cannot explain, operating on timing we cannot ignore, and as of now, no known natural object has ever displayed this kind of motion. Because this isn't motion, it's navigation. As data began streaming in from various telescopes locked onto 3I Atlas, one particular dataset raised eyebrows inside thermal imaging teams. And it didn't come from the bright side, it came from the dark. Specifically, the shadowed side of the comet, the hemisphere turned away from the sun, which, under normal conditions, should be cold, inert, and largely undetectable in the infrared spectrum. But it wasn't. Instead of dropping to the expected low Kelvin range, around -200 degrees Celsius or colder, the dark side of 3I Atlas exhibited localized heat pockets, not all over, not a general warming, but precise, repeating hot zones scattered across the unlit surface. These weren't random, they were shaped like hexagons. Each hotspot was roughly circular from a distance, but under closer inspection using filtered multi-band infrared overlays, the edges aligned with six-sided geometry. This raised immediate questions. Because nature doesn't often do hexagons at this scale, and certainly not in thermal profiles. The first explanation proposed was internal convection, heat from the sunlit side conducting through the nucleus. But even advanced thermal modelling couldn't replicate the pattern seen. Heat transfer should be chaotic, diffuse, and gradient-based, not clean, not geometric, not pulsing, and that's exactly what the temperature anomalies did. They pulsed. Every 27 seconds, each hexagon-shaped zone fluctuated in temperature by up to 3 degrees Celsius, as if something underneath the surface was activating, resting, then activating again. And the timing was synchronized across all visible zones, regardless of position. The European Southern Observatory released a confidential report to a group of interdisciplinary physicists detailing these findings. One section hypothesized that the thermal activity could be the result of buried crystalline structures or energy emitters, artificial heat sinks perhaps regulating internal processes. But that theory, though logical, was instantly met with the same resistance. If those structures exist, who put them there? The pattern didn't match any known chemical reaction, solar interaction, or geological process. More than that, the location of the hexagons suggested something worse: internal mapping. They were spaced evenly along longitude lines, equidistant, and symmetrical around what appeared to be a central axis of rotation. In other words, these weren't random thermal flares, they were nodes, energy nodes, timing nodes, possibly control or diagnostic nodes, but certainly not natural. One model speculated that the dark side of the object might contain embedded solar sinks, absorbing light during close passes and releasing it later as internal warmth. Another more speculative model proposed microreactors, compact energy cores buried beneath the surface to maintain operational systems during long-distance travel. Either theory pushes the object out of the realm of nature and into the realm of design. There is, however, final detail that changed everything. When the heat signatures were observed at their peak, a second set of minor temperature flares appeared, but above the surface. Roughly 30 meters above each hotspot, a faint signature hovered, visible only for 3 to 5 seconds before disappearing. It wasn't clear whether these were emissions, holographic fields, plasma discharges, or something else entirely. But they matched the hexagonal placement. Something above 3i Atlas was responding to what was happening inside it, and if there's one lesson in space observation, it's this. When both surface and atmosphere behave in synchrony, something intelligent is happening. Something is coordinating this object from the inside out, and on the dark side of 3i Atlas, that coordination is now undeniable. By the time 3i Atlas settled into its sideways orbital drift near Earth, optical observatories began noticing something profoundly wrong, or rather something that didn't fit with any known model of how light should behave when interacting with matter. From ground-based telescopes in Chile to satellite observatories in Earth's shadow, the reflectivity curve of 3i Atlas was quietly breaking known physical laws. At certain angles, the object reflected more light than its albedo would permit. At others, it dimmed so significantly that it almost vanished, as though the light itself was being absorbed, redirected, or filtered through something we didn't understand. It didn't behave like a rock. It didn't behave like ice. It behaved like a filter. Photons striking the object didn't scatter evenly the way they would with a dusty, volatile-rich nucleus. Instead, there were moments, small, measurable windows, where light was absorbed in a near-perfect curve, followed by delayed refraction from an entirely different vector. To make it even stranger, these light anomalies didn't correspond with the comet's visible surface activity. Jets would ignite with no photometric increase. Shadows would deepen without changes in angle or composition. The result was a kind of optical illusion at astronomical scale, one where the object's brightness wasn't just dependent on its position, but seemed to react to who was observing it. That's when the spectroscopic teams got involved. They scanned the object across multiple bands, ultraviolet, near-infrared, and even X-ray. What they found shocked them. Instead of a smooth thermal distribution as the sunlit side rotated, 3i Atlas exhibited hotspots, not in the sense of temperature, but in the spectral frequency of emitted light. These weren't random either. They shifted slowly around the object, defying orbital logic. One band would spike in the UV, while another would vanish in the infrared, all while the comet remained in full solar exposure. It was as if the object wasn't just reflecting light, it was controlling it. No natural comet has ever shown signs of optical modulation. But here, we had something that seemed to manage its photonic signature with deliberate rhythm. And the deeper astronomers dug into the light data, the more it began to look like an artificial system of concealment, something built to scatter attention, mislead instruments, or remain hidden unless viewed at precise alignments. The implications were staggering, because if 3i Atlas wasn't following the standard laws of light-matter interaction, then it wasn't just a strange rock, it was a machine, or a shell, or a layered object designed to cloak itself, to shimmer, vanish, and reappear depending on who or what was watching. And it had just positioned itself on Earth's side of the Sun. Observers tracking 3i Atlas during its orbital drift were already puzzled by its visual behaviour. But the return of the anti-tail brought a different kind of shock. This wasn't just a mirrored tail pointing toward the Sun. It was something that broke open the entire question of what this object truly was. In standard comet dynamics, an anti-tail forms briefly when Earth crosses the orbital plane of the comet. Dust particles left behind in its wake appear to form a reverse-facing tail due to optical alignment. It's purely geometric, not physical. But what astronomers saw on the morning of December 18th wasn't geometry. It was motion. Instead of forming from leftover dust or ambient solar wind flow, the anti-tail of 3i Atlas burst into visibility with structured acceleration. Jets fired into the sunward side. Not just gas, but mineralized fragments, traces of heavy carbonates, silicates that were far too dense to be casually flung into the solar vector. It was a deliberate reversal, and that reverse jet carried momentum. The anti-tail didn't drift outward slowly, it snapped into place. It bent around the body like a magnetic filament before elongating into a ribbon of heat and mineral trace that was dense enough to cast shadows in infrared. For some, it looked like the object was ejecting mass deliberately, a kind of controlled deceleration using the sun itself as a brake. For others, it hinted at something even more complex, a heat vector shield, or a solar-fed jet array meant to push back against solar gravity. But what made it even more disturbing was the timing. The anti-tail ignited only after the object completed a perfect lateral drift toward Earth's orbital path, almost like it waited for alignment. And this time, the anti-tail carried something extra. Spectrometers picked up high-energy emissions wrapped inside the dust. Short-wave pulses, not just reflected radiation, but outgoing waves that pulsed at predictable intervals. A signal. That word wasn't used publicly, but in off-record transcripts between observatory teams it came up repeatedly. Something inside 3i Atlas had just opened a stream, and it was pointing it toward the sun, or perhaps around it. Whatever the purpose, the shape of the tail, the composition and the behaviour no longer matched natural expectations, and Earth was now in the direct forward path of where that stream might flow next. While the surface of Earth remained calm that morning, something far stranger was unfolding above it, in the invisible upper edges of our atmosphere. The thermosphere, the region that begins about 90 kilometers above sea level and stretches toward the vacuum of space, began responding to something that wasn't there the day before. It didn't roar, it didn't shake, but it moved, with purpose. High-altitude observatories and orbital platforms began to detect what researchers now describe as non-ionizing shockwaves rippling across the thermosphere, expanding in concentric arcs from a single point, the drift path of 3i Atlas. These were not your typical gravity waves or auroral discharges. They weren't tied to magnetic reconnection events or solar flare residue. They had no known electromagnetic fingerprint at all, and that's what made them so disturbing. To be clear, these weren't shockwaves in the traditional sense. There was no explosive origin, no thermal radiation, no velocity that matched a collision. These were something else entirely. Silent distortions in density, spreading out like ripples in a pond. Except the pond was Earth's atmosphere, and the pebble had never touched the water. The thermosphere began shifting in pulses. Small pulses, regular intervals, as if being influenced by a repeating signal. Infrasound detectors in South America, originally built to detect illegal nuclear tests, picked up the first tangible traces, not noise but pressure differentials in the air, arriving every 7 minutes and lasting less than 3. Scientists initially dismissed them as local weather noise, but after cross-referencing with polar research outposts and balloon-based sensors in the stratosphere, the pattern was unmistakable. A silent system was operating above Earth, one that mirrored the path of 3I Atlas. Even more alarming, the wavefronts weren't fading. Normally, atmospheric anomalies like this, if they originate from energy bursts, decay quickly, especially in the chaotic thermosphere where solar particles are constantly stirring the mix. But these distortions remained stable for hours. It was as if they were being maintained. Teams from NOAA and the ESA's atmospheric division began running simulations. Could this be the result of vented material? A jet stream from the anti-tail interacting with upper atmospheric molecules? The models didn't support it. The shape of the disturbance was too clean, the repetition too precise, and the center of each pulse followed the orbital drift, not the Earth's rotation. That's not how atmospheric physics normally work, unless you're dealing with an external reference point. Something actively shaping the field from above, not passively reacting to it from below. One possibility gained traction in quiet briefings. What if 3I Atlas was emitting a low-frequency field, not designed to damage but to scan? Scan what? The density of the atmosphere? The electromagnetic profile of Earth's airspace? Or something deeper? The resonant signature of the planet itself? Because these waves weren't just reaching up, they were pressing down, bending the ion layer ever so slightly, not enough to disrupt satellites or GPS systems, but enough to be measured. And it gets stranger. Satellites in geostationary orbit recorded minor signal degradation in sync with each atmospheric pulse. The timing was perfect, not delayed, not diffused, synchronized. The implications were hard to ignore. Something up there, something riding the tail of an interstellar object, was interacting with Earth's atmosphere in a way no comet ever has. Not just lighting up the sky, not just releasing gas or particles, but causing structured, silent waves in a region where nature rarely moves with such clarity. And perhaps listening for what comes back. As 3I Atlas continued its lateral drift along Earth's orbital plane, teams from the European Space Agency and NASA began receiving data that at first seemed too subtle to matter. But those subtle variations quickly escalated into what we now call gravitational anomalies. These were not random fluctuations in the solar wind. They weren't magnetospheric noise or instrument drift. They were measurable deviations in gravity. The first hints came from Lagrange monitoring stations near L1, those deep space sentinels designed to detect solar pressure, gravitational vectors, and orbital balances. One by one, telemetry from these stations began reporting micro-variations in the gravitational field as 3I Atlas passed within range. These weren't dramatic. No satellites were knocked off course, but the readings were consistent, and they defied current orbital mechanics. The object was exerting influence. In the classical model of cometary physics, even a large interstellar object like 3I Atlas should behave predictably in the presence of solar gravity. The Sun's pull, Earth's subtle influence, even Jupiter's reach, all of it could be plotted, calculated, and corrected for. But these anomalies weren't fitting the expected models. Here's what changed. The mass distribution appeared to shift, but the object's acceleration didn't. That shouldn't happen. When a comet vents material, it alters its mass and usually changes velocity or spin. But 3I Atlas continued to behave as though it had a stabilizing force inside of it, something that counterbalanced every loss, every ejection. It was drifting sideways near Earth, dropping mineral-rich jets, igniting its anti-tail, and not deviating. So mission specialists did what any precision agency would do. They reran the math. But even with adjustments, no model could explain the readings. And then came the more disturbing realization. The gravitational field near 3I Atlas wasn't just fluctuating, it was oscillating. That's when speculation turned serious. Some began whispering about mass dampening systems, technology proposed in theoretical physics circles to reduce gravitational influence on an object. Not block it, not shield it, but oscillate it, to confuse tracking systems or maintain flight stability in chaotic gravitational zones. Could it be that 3I Atlas was using something like that? A resonance field? A core of variable mass that responds to gravity not passively but actively? At that point, the object's trajectory toward Earth gained an entirely new level of urgency. Because if this was artificial, if this was technology, then it wasn't just coming. It was controlling its approach. Engineers at the Indian Space Research Organisation and private contractors from SpaceX quietly began logging the anomalies into closed-door simulations. And what emerged from those simulations was even stranger. The gravitational pattern surrounding 3I Atlas wasn't centered. It orbited the core. It was as if the mass was not fixed inside the nucleus, but was circulating, and in doing so, it was creating temporary waves in spacetime that, while incredibly small, were measurable, especially as it approached Earth's L2 shadow zone. That final data point, the orbital drift of gravity itself, changed the status from anomaly to threat vector, not because it implied aggression, but because it proved intelligence. You don't stabilize gravity unless you need to stabilize gravity, and you don't oscillate mass unless you're hiding something inside. The object had just passed the point of passive classification. Now the scientific world had to consider, what happens if this thing decides to stop drifting and start maneuvering? As 3I Atlas neared its closest approach, an observation from a small spectrograph array in Argentina caught the attention of researchers worldwide. For 2 hours just before dawn on December 18th, a narrow region behind the object's coma, normally saturated with streaming particles, began to clear. What remained was not darkness, but transparency. Not optical clarity in the way we might imagine seeing stars through a gap. No, this was something more precise, more surgical. Instruments tuned to pick up minor fluctuations in spectral absorption noticed that light from distant stars behind the comet wasn't just being filtered, it was being momentarily untouched. This region behind the coma seemed to absorb nothing, reflect nothing, and bend nothing. It was as if, for a short time, space folded into a corridor, an angular slit that didn't scatter light, didn't diffract particles, and didn't behave like any gas cloud known to astronomy. The Argentine team assumed at first it was an instrumentation fault, but independent confirmation came just 30 minutes later from a balloon-based platform drifting over southern Australia. Their high-altitude cameras and wide-spectrum sensors caught the same gap forming, aligned with the comet's trajectory, but notably not centered on its nucleus. It was slightly behind it, trailing, intentional. The coma should be a chaotic environment, a boiling mixture of water vapor, carbon dioxide, hydrocarbons, dust, and ionized particles thrown into turbulence by the solar wind. There shouldn't be anything clean or still in it, but this window was still, almost mechanical in nature. That raised the most alarming possibility yet. Was this a vent, a sensor aperture, or something akin to a hatch? We still don't know. There's no record of any known celestial object displaying this behavior. Not even the famously stable nucleus of Comet 67P. The idea of a natural corridor forming in a comet's coma, especially one that tracks with the object's orbital drift rather than its solar proximity, is beyond current explanation. Some theories suggest 3I Atlas may be using an artificial field to shield part of its rear zone from solar interference, perhaps to protect something sensitive, a structure, a signal array, a propulsion mechanism. Whatever it was, the rest of the coma began to react immediately. Particle flow around the cleared window diverted as if encountering a physical obstruction, though none was seen. The tail bent more sharply, as though something shifted inside the object's field of influence. We weren't just observing a comet anymore. We were watching an event that mimicked intentional shielding. It's not every day that an interstellar object opens what looks like a gap in its own energy field, and then maintains it, without decay, distortion, or diffusion. Whatever opened behind the coma on December 18th was not a rupture. It was not accidental. It was a controlled exposure. And Earth was directly in its line of sight. For most of the morning of December 18th, observers across Eastern Europe reported something they couldn't quite explain. In remote villages, farmers looked up and noticed the sun dimming, not behind clouds, not behind haze, but shifting in tone. The daylight itself began to feel wrong. It wasn't a full eclipse. It wasn't even enough to register on standard weather monitoring systems. But to those on the ground, something had changed in the sky's quality. Like the colour spectrum had been rewritten, subtly but globally. When scientists finally reviewed hyperspectral satellite data, the pattern emerged. For just under 12 minutes, a diffuse, highly irregular shadow passed over parts of the Earth's upper atmosphere. But unlike a lunar or solar shadow, it didn't track with celestial mechanics. It moved with 3i Atlas. And yet, curiously, the shadow didn't fall directly underneath the object's location in the sky. It was offset, slightly to the east, mirroring the region where that strange Coma window had formed hours earlier. This shadow wasn't entirely dark either. It was spectral, a dulling of certain wavelengths, primarily in the green and violet bands, the ones tied to biological reflectivity and plant fluorescence. That raised disturbing implications. Was the object dimming light intentionally? Was this some kind of scanning mask? Was it trying to isolate certain wavelengths to see what Earth reflected back? What was more disturbing? Photos taken during that brief event showed strange banding in the sky. Horizontal waves, not clouds, not contrails, but subtle striations as if the air itself had been etched. Aircraft in the zone at the time, 2 commercial flights and a weather reconnaissance jet, recorded no turbulence, no loss of pressure, no visible anomaly. But their navigation systems glitched, just briefly. North drifted by 4 degrees, then righted itself. One pilot described it as flying into a room where the walls moved slightly. The phenomena vanished as quickly as it came, the light returned, the instrument stabilized. But the timestamp was exact. It occurred precisely when the rear window of 3i Atlas faced Earth, and just before the object reached its peak, observed luminosity. This was not a visual illusion. It was not weather. It was something casting an intentional distortion onto Earth's atmosphere. A shadow not of mass but of logic, a manipulation of how light behaves before it touches the ground. And the question that lingers, what was watching us from the other side? From the beginning, the tail of 3i Atlas has been our only consistent marker, one of the few predictable features of an otherwise chaotic object. Every comet has a tail. It's what forms when solar radiation and wind interact with the nucleus, blowing particles out and away. Most of the time, that tail points directly opposite the Sun. It curves slightly based on orbital motion, but we always expect it to follow the laws of physics. That's why what happened during the last 24 hours has shaken astrophysics to its core. Multiple Earth-based observatories, including Mauna Kea in Hawaii and the European Southern Observatory in Chile, began noticing something disturbing. The tail of 3i Atlas wasn't just bending, it was changing shape, changing speed, and most troubling of all, changing direction relative to the Sun's position. At 0314 UTC, the tail briefly formed a spiral. Let that sink in. A cometary tail composed of gas and dust spontaneously formed a stable spiral coil for just under 3 minutes. That's not something that can occur naturally in an environment dominated by solar wind. It implies magnetic control, or worse, manipulation of ejection vectors. It wasn't random. The curl had symmetry. Some compared it to a radio antenna, or a rotating sweep like something probing space behind it. But the implications go even deeper. Solar observatories that monitored the Sun's corona at the same time picked up minor fluctuations in solar wind pressure, and not from the Sun itself. The pressure pulse came from behind the comet. This violates the foundational model of solar wind propagation. Nothing should be able to resist or redirect the solar wind without a planetary-scale magnetosphere. 3i Atlas is far too small for that, unless it isn't acting like a natural object. Let's return to the anti-tail, the unusual forward-pointing plume that appeared several days ago and then disappeared. We now know it wasn't a static feature. It's part of a larger, 3-dimensional energy structure surrounding the comet. It can shift, reorient, and even reconnect with the main tail like a loop. It behaves like a plasma field under programmed control. And here's the kicker. Infrared data shows that portions of the tail cool before they curve. That's backwards. The tail should heat up as it interacts with the Sun. Cooling implies the object is selectively modifying what gets ejected and when. No other comet has ever done this. Not even Oumuamua. This goes beyond anomaly. We're watching a tail that behaves more like an exhaust system, a system that might be regulating thrust, direction, or even scanning geometry. It's no longer safe to describe it as a tail in the cometary sense. It's behaving like a functional system, one with multiple configurations. And if this is an exhaust or sensor structure, then 3i Atlas isn't just moving toward Earth. It's aiming. It happened during what should have been a routine update. NASA had scheduled a public live stream with its Jet Propulsion Laboratory to brief the press and public on 3i Atlas's latest position, behaviour, and safety risk. These updates are standard, procedural, usually dry, but this one was anything but. 15 minutes in, as the presenter was showing live thermal imagery of the comet's structure, the feed began to flicker. First the visuals, then the sound. The screen froze on a heat map image showing an unusually hot band extending outward from the nucleus. Not along the tail, but in a perpendicular arc, forming what looked like a looped halo. It should have been dismissed as a sensor artifact, but the NASA presenter didn't move on. He froze. His mouth opened, then silence. What followed wasn't just a delay, it was a full system shutdown. The live stream cut to black. An internal technical difficulty message appeared, but those monitoring the stream in real time noted something else. A hot mic. For 6 seconds, unmuted audio captured someone in the room saying, "That's not a thermal layer, that's a cavity. Something's inside it." Then total silence. NASA didn't resume the briefing. There was no transcript released, no follow-up blog post. For the first time since the 3i Atlas mission tracking began, the agency went completely quiet. The recording was pulled from the public site within hours. Mirrors of the video have been taken down repeatedly. Why? Theories range from structural discovery, a hollow segment or internal chamber within the comet, to data that showed the object responding to solar input. Others speculate that what NASA saw was a mechanism, something opening or rotating within the comet. The precise temperature readouts in that frame suggest layered engineering. We're talking insulation boundaries, thermal differentials too precise for rock or ice, and concentric shapes that don't occur naturally. The fact that this data leak happened live, and the reaction was panic, not protocol, speaks volumes. NASA doesn't shut down briefings over noise. They don't lock down video for ambiguous shapes. They don't go silent unless something has crossed a threshold that demands silence. And now we're left with a chilling possibility that 3i Atlas might not be a comet at all. It might be a deliberately engineered interstellar vessel, currently activating its internal systems as it lines up for closest approach. And NASA's silence might be the most deafening confirmation we've ever received. For days now, astronomers have been chasing every known wavelength to understand 3i Atlas. Optical, ultraviolet, infrared, and even microwave sensors have been tracking its emissions. But yesterday a new reading came in, and it left everyone stunned. It came from the Atacama Large Millimeter Submillimeter Array in Chile, ALMA, the most sensitive telescope network on Earth for detecting cold space matter and strange emissions. What it detected wasn't cold. It wasn't a known signal, and it wasn't random. The signal from 3i Atlas, recorded at a narrow band just above 1 terahertz, oscillated in timed intervals, not just in bursts like thermal radiation, but in structured pulses. That's not a tail, that's not coma activity, that's communication. The pulses weren't following any astronomical patterns. They didn't correspond to spin rate, sun angle, or solar wind interactions. Instead, they repeated in a precise pattern. 3 short pulses, 1 long, then 2 alternating peaks. Some have called it the first structured light code from deep space. Skeptics try to match the rhythm to data glitches or atmospheric interference. But ALMA triple confirmed the result. The emission source was not the Earth's ionosphere or a local magnetic storm. It originated from the core of 3i Atlas, and it wasn't a one-time event. The signal repeated every 92 minutes, the exact time it takes the comet to complete a rotational realignment, based on Hubble's most recent imagery. That suggests something inside is rotating, repeating, and possibly sending or scanning. Even more shocking, the emission aligns with theoretical proposals for light-based propulsion signatures, the kind of exhaust pattern that might occur if a device were using photon recycling or directional laser thrust. We're not saying this is a drive system. But the symmetry of the pulses, and the fact that they're modulating in both amplitude and interval length, is impossible to ignore. The discovery has since been classified by several observatories. Independent researchers have been asked to delay publication. One anonymous astrophysicist said the following: "This isn't like Oumuamua, that was a shape, this is behaviour." The pattern in the pulses may point to a language, not in symbols or sound, but in light, a kind of optical code, repeating over interstellar distances, possibly broadcasting, possibly probing, or possibly waiting for a response. And what makes it even more chilling is what came after. Because shortly after that pulse sequence, the comet slowed down by just under 6 meters per second. In open space, a deceleration of that precision, outside of a gravitational slingshot, is not natural. It's intentional. And now, for the first time in human history, we are staring at an object that not only behaves in ways we can't model, it might also be trying to speak. Most celestial objects move predictably across our sky. Even fast ones like comets and asteroids follow orbital paths we can plot. That's why astronomers use fixed star positions as a background grid to measure motion. But last night something broke that expectation. At Shurosufar 44 UTC, multiple skywatchers from different hemispheres, Africa, Southeast Asia and parts of Eastern Europe, reported something no telescope had captured before. The sky moved, but 3i Atlas stayed still. That's not how comets behave. Normally, if Earth rotates or the sky shifts, everything in space appears to move relative to our view, unless it's at geostationary orbit or closer. But 3i Atlas is millions of kilometers away, and yet, in a window of 4 minutes, the star field around it shifted while the comet held position, as if anchored to something outside our reference frame. This anomaly was verified not just by amateur stargazers, but by data pulled from the Very Large Telescope in Chile and the Subaru Telescope in Hawaii. Spectral analysis showed no movement from 3i Atlas during that window. 0 drift, 0 rotation, 0 translation. That's physically impossible. Unless the object is locked to a different frame of reference. One possibility, it's navigating by gravitational triangulation, not by visual starlight. Meaning, it's not positioning itself relative to stars, but to gravitational masses that we may not be accounting for. Another theory, it's operating inside a local space-time distortion. If that's true, then 3i Atlas might be using some form of field damping, a theoretical method where an object cancels inertia by coupling itself to a field that suppresses external motion. That's science fiction level stuff. But this isn't fiction. Every instrument that watched the sky that night agrees on the same thing. 3i Atlas did not move when everything else did. That makes it by definition anchored. Or worse, controlled from outside our frame. There are whispers that a similar phenomenon was observed decades ago, but buried in Cold War satellite logs. Back then, it was dismissed as sensor error, but this time it's real, it's global, and it's happening right now. And if this object isn't locked to our physics, then every prediction we've made about its path, its approach, its threat level could be completely wrong. It's not obeying the sky is obeying it. For weeks, observatories around the world have been triangulating the gravitational footprint of 3i Atlas using multi-sensor orbital dynamics. Essentially, we've been tracking how its presence subtly pulls on other known objects, asteroids, dust, and even background radiation, to understand its mass. And that's when the math broke. According to its size, estimated at around 6 kilometers in diameter, and its visible tail material, the comet should generate a predictable gravitational effect. But what scientists have now confirmed is a decoupling between mass and pull. In simpler terms, the gravitational influence of 3i Atlas does not match its estimated mass. Not even close. It's off by a factor of 4. If true, that means one of two things, both equally disturbing. Either the object contains a mass-dense core that is not visible or detectable by traditional means, such as heavy metals or even degenerate matter, or worse, it is surrounded by a gravitational field that is not native to the object. The first theory suggests the comet is more than it appears, a hollow shell surrounding an ultra-dense structure, possibly even artificially stabilized. But the second theory opens a darker door. A team from Caltech modeled the anomalies using simulations designed for gravitational lensing, the kind we see with black holes or dark matter halos. When those simulations were applied to 3i Atlas, the pattern matched a low-grade gravitational shell, as if the object was wrapped in its own field. That doesn't happen in nature. Comets don't have gravity fields stronger than their cores. That behavior only exists in theoretical constructs, like warp bubbles or engineered mass fields, and just days ago the Gaia Observatory confirmed something even more unsettling. 3i Atlas caused a detectable redshift compression in starlight, passing just behind its projected position. A kind of ripple, like space itself, was slightly bending around it. That should only be possible if the object is warping space-time, or if it's moving through a gravitational mechanism we don't yet understand. NASA has gone silent on the latest telemetry. The ESA hasn't updated its mass approximation since the anomaly was discovered, and yet privately, observatories are updating their internal risk models, because if this object is not bound by traditional gravitational law, then it can change speed, trajectory, or even mass effect without any external force. It can, in theory, choose what gravity it exerts, which means all of our Earth impact models, they're no longer reliable. For months, astronomers have insisted that 3I Atlas posed little risk to Earth. Based on its projected course, it would pass at a safe distance, delivering nothing more than an impressive light show. But one amateur astronomer in Finland noticed something that everyone else missed. The trajectory error margins have been converging, not diverging. Normally, as a comet approaches, our data improves and the range of possible paths narrows. But in this case, something unusual was happening. The most likely path was consistently drifting closer to Earth, not just because of better data, but because the object itself was adjusting. Each course correction narrowed the margin toward a path that intersects a gravitational corridor known as the Earth-Lunar Transfer Arc, a narrow region of space that allows objects to drift toward Earth using minimal energy. Think of it like a natural highway through space, where gravity does most of the work. And 3I Atlas is now entering that lane. Worse, this change wasn't announced by any major agency. It was quietly noted in a revised table published by the Jet Propulsion Laboratory, but not highlighted. No press release, no public warning. Why? Because officially it's still not a collision course. But off the record, several orbital analysts from different continents are starting to agree that something changed around December 13th. That's when the object's acceleration suddenly matched the curve required to enter a slingshot arc toward Earth's vicinity. And since then, it's shown minute course corrections, almost as if it's steering into that path. These aren't random perturbations, they are targeted adjustments, and when cross-referenced with the previous chapters, the gravitational anomaly, the strange pulses, and the unshifting sky, it paints a pattern. This object may not just be heading toward us, it might have chosen this path. And if that's true, then every error margin on NASA's charts might not be a safety cushion. It might be a warning we've misread. Or worse, it might be the exact distance it needs to make contact. As of this morning, 3I Atlas has entered its last orbital window before passing by Earth. What was once a slow-moving enigma in the sky has now become the most unpredictable and potentially intelligent object ever recorded in our solar system. It no longer behaves like a comet. Its tail is no longer consistent with volatile ice venting. Rather, it shows structured pulses. Its spin rate is not random, but shows a clear synchronization pattern that has now looped exactly every 6 hours. Its gravitational profile no longer matches its visual mass, and perhaps most disturbingly, its trajectory aligns perfectly with the only corridor in near-Earth space that allows for repeated returns. This isn't a flyby, this is a loop. According to new orbital mechanics, data published privately by 2 separate labs, one in Italy, the other in Arizona, 3I Atlas is moving into a resonant drift. That means the object will not simply pass Earth once, it will return again and again, if undisturbed, like a pendulum crossing our orbital space every 6 to 8 weeks. That makes it not a visitor, but a resident of our neighbourhood. The object's incoming angle now appears optimized for solar energy capture, spending maximum time in our star's light envelope. Its light spectrum signature, once passive, now responds to solar flares with increased tail brightness, like it's harvesting energy from the sun's electromagnetic output. And then there's the silence. In the final 24 hours, no agency, NASA, ESA, JAXA, or even ground-based telescopes, has published a single update. It's as if everyone received the same instruction: stop reporting. But amateur observers haven't stopped. Dozens of live streams have caught strange flickering geometric shadows behind the object. Grids, frames, even lens-like curves, none of which resemble natural phenomena. Some have started calling it a construct, others have stopped calling it a comet altogether. And as the closest approach now enters the final countdown, one terrifying possibility remains unspoken, but undeniable. What if this wasn't an arrival? What if this was a return? And Earth was never the destination. It was the rendezvous point. Every time we've encountered an unexplained object in space, we've used the same fallback: label it, study it, then forget it. But 3i Atlas is not fading, it's sharpening. It's shifting behaviour, responding to light, curving gravity, and aligning itself to orbital corridors with mathematical precision. We've entered a new phase, where comets are no longer frozen relics, but possibly engineered tools, where silence from space agencies is no longer caution, but possibly containment, and where the next signal won't be light, it might be arrival. Thank you for watching. If you're tracking this story, let me know where you're listening from and what time it is. Like, subscribe and stay alert. We'll be watching the sky together. Because this isn't over. 3i Atlas is not leaving. It's staying. And we may only be at the beginning of something Earth has never experienced before.